Express the following rational expressions in simplest form, stating the non-permissible values as restrictions. In A, we have 4a squared over 16a. Here we can reduce the numerical coefficients. We can divide numerator and denominator by 4, leaving us with 1 and 4. And then the a in the denominator cancels against one of the a's in the numerator. So now we're left with a over 4. Now the non-permissible value here will be 0. A cannot equal to 0. Why? Because if a equals to 0, this a would be 0. 16 times 0 is 0. We cannot have a denominator that's 0. So that's why a equaling to 0 is a non-permissible value, and we have to put it in like this as a restriction. In B, we have 25 y to the power of 4 over 10 y to the power of 9. We can divide numerator and denominator by 5, leaving us with 5 and 2 as the numerical coefficients. And then we can cancel the 4 y's in the numerator against 4 of the y's in the denominator, leaving us with just y to the power of 5 in the denominator. And the non-permissible value here is going to be that y cannot equal to 0, because if it does that, the denominators will become 0. In C, we have a product of two binomials in both the numerator and the denominator. The 8 minus 8s cancel against each other, leaving us with a plus 3 in the numerator and a plus 1 in the denominator. The non-permissible values here would be -1. So a cannot equal to -1, and it cannot equal to 8. Because if we look at this first binomial here, if a equals to -1, -1 plus 1 is 0. So we cannot have 0 in the denominator. For the second binomial in the denominator, if a equals to +8, we're going to get 8 minus 8, which is 0. So a cannot equal to 8, +8. And then finally, in D, we have two binomials in the numerator being multiplied. And then we have a monomial times two binomials in the denominator. The x minus 2's cancel, and we're left with x plus 7 in the numerator and x times x plus 14 in the denominator. The non-permissible values here would be that x cannot equal to 0, because if x equals to 0, we're going to end up with 0 here, times these two binomials, but because we're multiplying by 0, the whole thing will be 0, so x cannot equal to 0. X cannot equal to 2, because 2 minus 2 would be 0. And finally, x cannot equal to -14, because -14 plus 14 is 0.